Okay then, final session of the day, I believe. So this session's on Ethernet APL, which for me and the area of process automation I work in is a very exciting technology. So I'm hoping to infuse that similar excitement on you guys, even at this late stage of the day. Throughout the day you'll have heard Profinet PA. That is effectively what we're going to be calling the Profinet aspect that uses Ethernet APL. So I'm going to be talking about Ethernet APL, and this links into this Profinet PA that we've been talking about or hearing about during the course of the day. So, what shall I talk about? Let's have a look at the business situation and the environment at this moment in time, and why such technology like Ethernet APL has even been considered and why there's a requirement for it. I'm going to introduce you to Ethernet APL and give you then a summary of where we're at and what's next. I guess the first question to the room, just to see if anybody's still awake, is: are people familiar already with Ethernet APL? Anybody? Okay, a few hands. So it's a new topic to some people, which is great. Some people are aware of this, which is also good. So let's get stuck in. So, digital transformation in process plants. We've talked quite a lot today about this Industry 4.0, the urge that people have for data, and this is because people are understanding now why additional data, how additional data could benefit your organizations. So that's great. And if we think about devices on a process plant, your sensors, your actuators, they're not just dumb devices these days. There's a lot of information in those at the bottom end which could be useful to add to this vast amount of data which people are going to analyze and create great decisions by. And of course, we've been talking about how why Profinet is so popular, because Ethernet has a lot of advantages and people are comfortable with Ethernet. So there's lots of digital transformation going on in industry, and this is also true of the process industries. If we take a look at the process industry and how technology has evolved over time, 4 to 20 milliamp analog. I'd like to say this is a thing of the past, but there's still an awful lot of this out there, 4 to 20 milliamp, because it's what's always been used and it works. But 4 to 20 milliamp allows you to have one measurement, one scaled value out of a piece of equipment. So you can't access any of that additional data for any reason, whatever it might be. You just can't access it. So that's no good. However, there is the HART protocol on top of 4 to 20, which does allow you to get access to additional measurements. It allows you to remotely access the device, perhaps for configuration diagnostic purposes, perhaps to get some of this additional data out for other reasons. But of course, to get it onto Ethernet, some sort of protocol conversion gateway is required, and HART for accessing large amounts of data is very slow. And then we move on to field bus. So this is how it's transformed. This is kind of where we're at the moment. Field bus, things like Profibus, multiple measurements can be extracted from your process automation equipment. You can remotely access the devices, but again, some sort of gateway is going to be required to get from your Ethernet networks to your Profibus networks. It's relatively low speed when we talk about it in comparison to Ethernet. I mean, I've always stood up here and said it's extremely fast because I've always compared it to things like HART, but actually when we think about field buses in relation to Ethernet, especially Profibus PA, for example, it's actually quite a slow protocol, and it's only half duplex. This is quite an interesting point. Ethernet is full duplex, so it's receiving and devices are receiving and transmitting at the same time. Field bus is half duplex, and it can be quite complicated. Field bus, we try and make it as easy as possible as a group. Field bus, But of course, there's things like termination resistors that people have to understand, and lots of different intricacies that you need to understand to make sure your network is installed correctly. So Ethernet. We know Ethernet, and we've talked about Profinet all day. Many measurements can be pulled out of devices. You can access all that additional data from the devices across Ethernet without having to change from Ethernet to 485 or something like that. So it's effectively one single network. Okay, there might be different protocols on the network, but it's one single network. And of course, we've got high speed, full duplex, potentially high bandwidth application, and there's that nice vertical integration between the OT and the IT world. So this is why Ethernet is popular. And of course, we go back to the process plant, and there's an Ethernet gap. So if we look at this pyramid here, you've got enterprise levels where Ethernet is king. You've got the plant-based level where Ethernet is used for the control networks, the supervisory networks. But then generally there's a gap there, and there's some sort of conversion has to happen to another network to access these field devices in a process plant. And that could be converted to Profibus PA, it could be converted to Foundation Field Bus, it could be to go onto your 4 to 20 heart. There's some sort of conversion there, there's an Ethernet gap. And to summarise, current technologies in the field have limitations. The lower speed, you've got to require that protocol conversion, no seamless data access because of the gap there. So for this data-driven world, which we're moving into, this is not very useful. And we don't want the stuff at the bottom to be forgotten, because there's lots of good data there. So this is where Ethernet APL comes in. So let's have a little look at it. Technology, what is it? A 2-wire Ethernet for process automation and hazardous locations based on IEEE and IEC standards. So right there, that tells you exactly what it is and why this fits the process world perfectly, because these are the requirements of the process industry. 2-wire, so power and communication down a single pair of cables. This is what has always been used. You know, 4 to 20 milliamp was the same. Field bus like Profibus PA is the same. This 2-wire works. Hazardous locations, you know, process plants have ATEX explosion areas. So, and there's equipment in these areas. So we need to get Ethernet into these areas safely somehow. Long distances as well, we'll see this in another slide further on. There's, you know, in factory, your distances aren't all that far between bits of equipment, between your switches. That 100-meter length of Ethernet is probably okay. In process plants, that's no good. So benefits, again, this is straight off the Ethernet APL website. We kind of already talked around these benefits. Enhances the value, extra data, dramatically simplifies installation, configuration and maintenance, and designed for a workforce trained in IP technology. So I guess that last statement's interesting, because I think people have a general feel that they understand Ethernet. I think we've maybe seen today that when you come to industrial Ethernet, there's other things to take into consideration, but the view is that people like Ethernet, and it works. Now another video which I'd try and play, but there's something very odd with, let's just see. Yeah, it's not going to play it again. What is going on with your laptop? Sorry? Ah, is that where's this? Ah, that'll be what it is. Glad we've got somebody who knows what they're doing in the audience. There we go. Maybe. Let's just try it. There we go. Let's just watch this overview video. Okay, yeah, nice glossy video there from the Ethernet APL group, just to highlight the benefits. So let's just delve into that a bit more. So why is this required? I mean, the danger of repeating myself, let's just have a little look at what we know as Ethernet today. We're all familiar with this cable on the slide here. This is a standard Ethernet cable with an RJ45 connector on. This is generally a 4-wire, potentially 8-wire. Of course, there's industrial versions of this for things like Profinet. This is generally one you'll find in an office. But of course, any equipment connected to this, in general, requires a separate power supply. Okay, yes, there's power over Ethernet options, but you know, to power something meaty, that's not very useful. The speed of this is 100 megabits per second upwards, because obviously we've got faster than that as well. But of course, there's a limitation on distance. That really, you can only run that between switches or components of 100 meters. So whilst it's really good for what it's there for, it's not so good for the hard floor of a process plant. So let's look at what Ethernet APL brings to the party. First of all, rather than RJ45 plugs, we're going to be looking at connectors and terminals. 2-wire cable. So there's the new cable. Single pair. Power and data down that same cable, exactly like Profibus PA. Explosive hazardous area usages, so this can be run into the hazardous areas if the correct components are used with no danger of explosion. And high speed and bandwidth, which is what Ethernet brings to this party, up to 1,000 meters cable length. Now that's much more useful for the process industries. Nice long cable runs where your Ethernet is going to work. So Ethernet APL is an organisation formed of multiple components, multiple companies, manufacturers within the process industries, as well as technology groups like ourselves, PI. We're all part of this Ethernet APL project. And all specifications and guidelines for Ethernet APL are finalised and they are officially available. So actually, this is the first time I'll be able to stand up and talk about this and actually say, we have something available. You know, it's always been theory, it's always been, we're almost there. We are there. So we've got IEEE standards for long reach 2-wire Ethernet. We make use of an IEC standard for 2-wires, so 2-wire intrinsically safe Ethernet. Port profiles have been generated to make connectivity and cable specs nice and easy. Engineering guidelines have been written to assist with supporting planning and designing of APL, and conformance testing has been set up to ensure that any components that manufacturers make to connect and use Ethernet APL will work with one another. So it's launched. 2021, this technology at Akima Pulse, as it was called this year, was officially launched. This technology is available and it's out there, in theory. Because of course, COVID hit. And whilst the technology is available, the manufacturers and the devices aren't quite out there yet. Because of logistics and chip shortages and all sorts of stuff. So whilst the technology is launched and it's available and all the specifications there, actual hardware, so instruments and valves and all the equipment that you would use in a process plant to connect to this sort of thing, we're looking at next year really, Q2 next year. Certainly I can talk from Endress+Hauser's point of view. We're bringing stuff to market Q2 next year. And I suspect it'll be very similar for these other companies you see on the board. There may already be some bits and pieces out there, but the actual whole host of stuff you're looking at next year. So, summary and advantages. 10 megabits per second long reach. Okay, I'm waiting for someone to say, hang on, you said it was fast. 10 megabits per second is pretty damn quick compared to what has been available for this sort of application in the past. So it may not be the 100 megabits per second as standard Ethernet, but it's very quick for what you're trying to do down at the plant bottom. Plus power, plus explosive environment, plus Profinet. Perfect. So if you look at your plant life cycle, you've got your homogeneous network topology without protocol conversion. You've got easy error-free installation because it's 2-wire and it's polarity independent, so that's pretty useful. Simplified integration, so no scaling like the old days of 4 to 20, automatic discovery, so all the benefits of Profinet that we already know filter down into devices connected using Ethernet APL. High performance and remote access, efficient troubleshooting, data access for second channel. So again, all the benefits and things we've been talking about Profinet today. This is Profinet, there's no difference, it's just on 2 wires down to the field devices. And if we look at some of the topologies, you've got you'll see here there's a couple of important network components here which are required for APL, the use of APL, and that's these field switches. So you can't just take a standard Ethernet switch because obviously APL is 2-wire power and data on that single pair. So there needs to be some Ethernet switches which allow for that to happen. So but you can see here, you can have general star arrangements here with a loop, a redundant ring at the top there, perhaps from your to the switches. You've got trunk and spur topologies, so all the topologies that were used for the field for Profibus PA, for example, are still applicable. You can see here you've got the APL power switch, which is allowing you to do a trunk line through various different field switches, and then you spur off to the devices. And you can see here you've got the different ATEX zones which are covered here as well, with using the relevant network components. So if anyone's ever designed a Profibus PA network, that looks extremely similar. There's no difference there. You just need to use slightly different networking components. Just a quick note on hazardous areas. So Ethernet APL conforms to this IEC standard, which is 2-wire intrinsically safe Ethernet, which has, like any of these standards, lots of good information about the interoperability, simple planning and installation rules, which if you stick to, you're covered by the intrinsically safe stuff. And yeah, the FISCO concepts, the field intrinsically safe concept, which was used for Profibus PA, is also adapted for Ethernet APL Profinet. So from an intrinsically safe point of view, from a hazardous area point of view, you're covered when you use Ethernet APL. Cabling, same as Profibus PA, which is great because you really wouldn't want to have to rip all your Profibus PA cable out. He's got one at the back. We want it in green though, please. Green for Profinet. Same cable. So yes, Profibus PA is not a technology that's disappeared. It's not just going to suddenly turn off. However, as you look to migrate and add, expand networks and move things to Profinet, the good thing is that you won't need to rip out any cabling from a Profibus PA point of view. The same cabling can be used. And again, we're talking screw or clamp terminals and M8 and M12 connectors for connection in the field. And I think this is always important because I have fallen into a hole in the past where people have got very confused about, what do I need to change everything out? Is this protocol going to work? Is this protocol going to work? Yes, it is. It's Ethernet, but it's a physical layer. So Ethernet APL is a physical layer, just like standard Ethernet is a physical layer. Gigabit Ethernet is a physical layer. Wi-Fi is a physical layer, and that's all about the physical aspects of what what components you need and how the data is transmitted electrically. All of the stuff that goes on above it, the different protocols, the different links, layers of the Ieee model are not affected. So it's just Profinet, as we've talked about all day, just through a different set of type of cable down to different devices. And because of that, obviously we're at a PI event today, but when we talk Modbus TCP or Ethernet IP, again, that will all be available by using to these field devices in the process world by using this Ethernet APL physical layer. So let's just compare that to finish off with some of the existing technologies for process plants. So we mentioned these already: single pair cable, HART field bus, clearly Ethernet, standard Ethernet as we know it. No, that's at least four wires, if not 8. Ethernet APL, yes, tick for the process industry. Data rates, you can see here, when we compare it to HART and field bus, so HART was 1.2 kilobits, field bus was 31.25. Ethernet APL is 10 megabits per second full duplex. There is an aim or a dream, I don't quite know where it stands officially, to get Ethernet APL to 100 meg at some point in the future, but I think that would, yeah, I don't know, not sure. 10 megabits per second, absolutely fine. Reference cable, compare it to field bus and Ethernet APL, type A, exactly the same. Trunk length, 1,000 meters compared to 100 meters of standard Ethernet. Polarity independence, Ethernet APL is a big tick there, so that's really handy from an installation point of view. The amount of times I've gone around and had to change cables around on networks and that's got it working is crazy, so that's great to see that's been included. Intrinsic safe option, yes, we've already said that. And of course the important message here, one network technology from field to enterprise. So none of this conversion going on, seamless data access for your control side, but also your IIoT Industry 4 side, depending on what you're doing with the data. So effectively that gives us big green ticks in everything that the process industry requires from accessing devices in the field. So Ethernet APL as a body have provided and produced some engineering guidelines for Ethernet APL, which talks about switches, cable types, the field devices which have been certified for Ethernet APL, example topologies, power considerations, especially when you come to sort of the ATEX requirements, installation of APL networks, so how to lay the cables correctly, connecting the devices properly, and also quite usefully some migration examples as well. So what's the best strategy if you want to move from Profibus PA to Profinet in the future? What about if all my plant is 4 to 20 HART devices? How can I consider slowly upgrading to using Profinet and making use of the Ethernet APL? So lots of good documentation there, really worth a read. Yeah, really good stuff. So that's Ethernet APL. So just to summarise and see what's next, I suppose. As I said, this year the technology was launched at the ACHEMA fair in Germany, and actually up to that point it wasn't just a load of people sitting in a room deciding this is going to work. There was extensive field tests went on, and it wasn't just a small company who was testing this either. It was BASF, so big player in the chemical industry. Spent a lot of time testing a multi-vendor installation at their site over in Germany. You can see some pictures of it, of the sort of setup here, the control side here with Profinet networks and control systems, and then the APL side up here with, you can see some valves and some instruments and all sorts of good stuff going on there. And here's some of the advantages that the customer provided. They saw it as easy and flexible to install, very easy to commission devices, using FDI tools, funnily enough, through the Profinet network. Saw that it was stable and fast Ethernet connection across the 2 wires. And of course, as well as the control side, the control data, that second channel of data in parallel to what was going on control, very easy to access and high speed of getting that data to wherever it needed to go. So some really good feedback from a customer in an industry that has either stuck, certain parts of the industry have moved to things like foundation field bus, but there's still quite a lot of the industry which we're using 4-20 HART and sort of existing distributed I/O type installations. So for them to grab hold of this and move this through their company, they have a number of projects now set up over the next 5 to 10 years to move various plants in the world across to using Profinet, utilising Ethernet APL. That's a real good news story, I guess. So the next topic that they're looking at is safety. So Ethernet APL in safety applications, utilising ProfiSafe and that sort of thing. I don't have a full in-depth understanding of where they're at with that, but that's the current focus is to be able to define the use of Profinet, utilising Ethernet APL from a safety aspect point of view. And it says at the bottom there, white paper available soon, so we'll watch that space. So final slide. With advanced physical layer for Ethernet, the vision becomes reality for process plants. It's a happy story. 2 good websites for further information. The Profibus website covers Ethernet APL, obviously focusing it on Profinet and what we're calling Profinet I keep on saying Profinut. I think it's all that coffee I've had. Profinet PA. So this is what Profinet PA is. There's no difference in terms of what it's doing from a protocol point of view, but it's utilising this new physical layer to talk down to the process instruments, process devices, and of course there's the Ethernet APL group website as well, where there's lots of shiny videos like I showed you at the beginning, and lots of good information as well. So I hope you found that interesting. If there's people from the process industries here, this is really a technology to look into. It's really going to help move the process industries forward with this topic of Industry 4.0 and all that sort of good stuff. So yeah, thank you for your time. Cheers.